So here's problem number 61 from section 3.6, and we're just going to take a really quick look at the effect of doubling the frequency on velocity, acceleration, and jerk. All right. We're going to do this problem twice. We're going to do it with the position as defined here, where S is equal to A cosine 2 pi bt. Velocity then is going to be the first derivative with respect to time of this, which is going to be negative A sine of, the inside stays the same, and then the chain rule will give us an additional 2 pi b. If we clean that up a little bit, we get negative 2 pi a b.
Wouldn't it be 4 pi?
No.
Not yet. This is going through it the first time.
Okay.
All right? And then this is going to be times sine of 2 pi b t. The acceleration, oops, not parenthesis. The acceleration is going to be the derivative of velocity, which is going to be negative 2 pi ab. Derivative of sine is cosine, and then we have a 2 pi bt, but then we got the chain rule again, which will add on an additional 2 pi b, and if we clean that all up, we're going to end up with negative 4 pi squared b squared cosine with
What
that.
happened to A?
Yeah, what happened to
A squared, B squared.
No, just A.
A, B squared, yeah.
Okay. So I forgot that. Thank you for reminding me. And then lastly, the jerk, which was Steve Martin's very first movie, 1979, I believe. The jerk is, I was in 9th grade. It's memorable. All right.
Okay,
It
4
is
pi.
negative 4 pi b squared
No, it's
a.
positive, 'cause the
Okay, hold on.
Sorry.
I've got the multiple. I've got that standing constant.
Right.
Plus I've got the negative sine 2 pi bt. And now I've got the chain again of pi bt, or pi b, 2 pi b. And when we clean that all up, like Noah said, it's going to be positive. It's going to, sorry, not, it's going to be positive, and it's going to be 8 pi cubed a b cubed sine of 2 pi b t. Okay, and so that's doing it with the function as is. Now we get to do it all over again, but now we get to say what happens when we're not using b, but rather we're doubling b. We're using 2b, or not 2b.
That is the question.
All right. So if position is now given in this new situation as a cosine 2 pi 2b t, which I will clean up as a cosine 4 pi bt, the velocity is going to be, and I won't go through it as explicitly, but it's going to be negative 4 pi a b sine of 4 pi b t. The acceleration will remain negative, but this time it's going to be 16 pi squared a, I forgot the a again, b squared cosine of 4 pi bt, and then the jerk is going to be 64 pi cubed a b cubed sine of 4 pi bt. So comparing the two, essentially the jerk ends up being 8 times as large as the original jerk with the original frequency. Now again, the solution and the odd problem answers basically say that kind of doubling is typically enough to tear apart the engine. Yeah. Okay. And you can see essentially the eightfold increase. Okay. By the way, these same kind of phenomena exist in terms of gas mileage as you increase your speeds.
Right.
The additional air resistance at the higher speeds cause a much larger than just linear decline in gas mileage. Same thing with impacts of cars at higher speeds. There's not a linear relationship, but an acceleration or deceleration problem, something on a fourfold change. So these facts and the fact that these doublings really have a huge multiplier effect are really important from the engineering standpoint. All right, and that is problem number 61. Does anyone have any questions before I save this recording?
65 too.
Let me save that, and let's go to 65, and then we're going to come back to the lecture. All right.